dump that hot distillate into your utility media, and the reboiler is ultimately going to be completing that closed loop with your product, so transferring that heat back over to your product. Some other critical pieces of equipment and kind of designated by the utility or the product side. So the vapor separator is often mounted on the outlet of your steam generator or your evaporator. So it's going to let your droplets fall back down and recondense back down into a liquid. And in some applications, it can be used for your level control, which can control the amount of heat that's ultimately transferred to your utility media. Compressors, which we'll hear more on that later. How you're going to ultimately handle your condensate, how you're going to recirculate that in a closed loop. Your subcooler, this is going to be starting the product contact side, so ultimately cooling your product back down to a reasonable temperature. Non-condensable evacuations, ultimately going to get rid of those off gases or things that can't condense in your product. And your pumps, so I'm pretty sure we're all pretty familiar with pumps, but getting the fluids from point A to point B. So here's an example layout of some equipment. So you'll see those pot stills, which you're probably pretty familiar with on the right. In the center, you're going to see some steam generators or evaporators with the line arm from the pot stills. Subcoolers mounted below that. Cyclonic separators in the center. Compressors are going to be on that bottom left side, and then your reboilers on the left as well. So 2 lines, one for the liquid to go back into the pot stills after it's been heated, and then the other for the vapors. So that brings me to the 2 types of steam generators or evaporators. I'm sure there are more, but just the falling film evaporator style, which you're probably more familiar with, the calandria style, and then the plate and frame evaporators. So we've heard about some falling film evaporators, but some advantages of doing a plate and frame style evaporator, as shown in the top right, is that there's less fouling typically and easier to do maintenance on instead of having a rigid heat exchanger. The ability to change the capacity if you have changes in your process or usage. And since it's just the overall footprint of the system. So if you look in the bottom right, you'll see it can be as small as 50% of the falling film evaporator style. And just with the orientation, which I'll touch on later, you don't always need a recirculation pump to circulate the fluid inside. Plate and frames are great, but there isn't, it's not always a perfect application, especially with high fouling media. So just keep that in mind. It's going to depend on the product ultimately that you're going to be transferring heat to. And then a couple of other design considerations. A lot of this can seem like a lot to put together, but I'm pretty sure we've all worked with Legos before. If you can chunk it down into each piece, start with your product. What do you want to do with it? What materials of construction are important? How you want to clean your system? Ultimately, how you want it to run and what amount of energy savings that you're looking for. And then just some applications in other industries. Anywhere you're trying to remove water ultimately from your product. So fruit juice, sugar refineries, water extraction, sodium hydroxide. This is a proven technology, and whether it's in bourbon or in other industries, it's been proven to save energy and reduce utility usage. And with that, I'm going to hand it back over to Kurt. Perfect.